So I am introducing Amy Laviers. She's here from the University of Illinois at Urbana-Champaign. She's the director of the Robotics Automation and Dance Lab, known as the RAD Lab. She's a recipient of the 2015 DARPA Young Faculty Award and 2017 Director's Fellowship. Her choreography has been presented at Merce Cunningham Dance Studio. She's also the co-founder of 2 startup companies. This could probably go on forever. Prior to UIUC, she held a position as an assistant professor in systems and information engineering at University of Virginia. Oh, and I'm sorry, I didn't even mention you're in mechanical engineering at UIUC. She completed her PhD in electrical and computer engineering at Georgia Tech with a dissertation that included a live performance exploring stylized motion. And finally, her research began in her undergraduate thesis at Princeton University, where she earned a certificate in dance and a degree in mechanical and aerospace engineering. As if that's not enough, now she's going to give an awesome talk.
Thank you so much, Elin. I have really enjoyed the last 3 days here at UW. I've been saying UW to sound like I'm in the know. And I had these 2 talks, and then I switched which one I gave on Wednesday versus Friday. So my goal with this talk was to really sort of zoom in a little more on process, which conversationally I think has been the right choice. And then I will do that, but I'm also going to try and give you a little bit the frame I used on Wednesday. How many were there on Wednesday? Just so I know, so if I don't repeat myself too much. Only a few. So I mean, I'm like, even in this moment, I'm like, I should just give Wednesday's talk again. But this will be more in-depth, more informal, hopefully, and conversational. I tried to make it a little more open-ended. But you'll still get some of the flavors that were there on Wednesday. And I heard it's recorded, so you can all watch Wednesday's design seminar as well. Oh, expression. That'll be my transition here. Expression, right? We associate it with this side of emotion. And I gave this panel thing. I was on this panel that was all about questions. And Naomi put me on the panel. She said, you're all about asking questions. You're going to love this panel. And indeed, I did. I loved the idea of formulating. I had to introduce myself only as through questions. And somebody asked in the audience, like, what is in the hyperspace around question and answer? Question and answer is one way we could look at the world. And what's around question and answer? And I think in the context of the university, we pose questions, you give answers. We give answers, you find out if they're right. You know, it's this one way of working. And it's a very thinking level of working. And so I just wanted to start the talk off. Really, this is cueing to something at the end of the talk when I'm going to finish with a story. But I wanted to just point out that sometimes, how are you feeling today? Is there a real answer to that? And so I'm going to start, and you could do this alongside me. I have a very difficult time figuring out how I'm feeling. So sometimes this wheel is actually really helpful. And I can just scan it and try to figure out how am I feeling. And I don't know, but maybe I'm definitely energetic because I've been lecturing already over there on the floor. So I'm feeling energetic, probably a little inferior, like always, right? When you give a talk, there's that level of inferiority. So I just wanted to honor that we're all feeling something. And the way we're feeling changes what we're going to think about the talk. And it's going to change how I'm going to give the talk. So responsive, I feel very responsive. All of these are all over the color wheel. So to our conversation earlier today, I don't think that I'm necessarily things that are right adjacent to one another. I'm many things at once. But we think of this, and the other reason I like to have this visual guide, we think of this as internal state, something about my internal state. But of course, my internal state is more than just how I'm feeling. It's what I'm thinking, and it's what I'm sensing. So I have all these things going on inside, but I have at least this many different possible internal states, but probably a lot more, right, than just this wheel. But I wanted to just start from a place of internal and about feeling and how you feel about something, what you value, what you subjectively experience is like a huge part of what we can do as intellectuals. And I'll come back to that at the end of the talk. But I just wanted to start with a grounding moment of honoring. So just for your second, I'm going to stop talking, look at the wheel, and try to place where you are on the wheel. You don't have to say it out loud. Just do it for yourself. So the thought is that what you are on the wheel is somehow expressed in your behavior. Maybe you're hiding it, maybe you're working actively to hide it, maybe you're trying to project a different interior state. But we have this idea that movement translates from interior state to express information in the environment. And I have these examples, I gave these on Wednesday too, but this is it, right? Like animals move and other animals move in response, and that means there's some information that's passed back and forth. Like we talk a lot about this in fish. We model this with continuous equations of motion, right? In fact, we have models that seem to predict certain elements of swarm behavior. But if there's information passing back and forth, how do these continuous models capture that phenomenon? I also like this picture, which might be a little hard to see with these lights, but you see a man in water. Similar environment, completely different posture. I can't even see his face, right? But from his posture, I get the sense of a very different interior state for both of these people, or internal state for both of these people. So there's something expressed, informative about these postures. And the way that I think about this, and I try to be very rigid with this model because it's like a classic model, is to look at this the way Claude Shannon looked at communication. And to try and understand, what is the information source? How big is it? Like, how many bits do I need to describe the information source? What is the receiver? What languages do they know? What's their decoding scheme? And then what's the channel? What's the context of this interaction or this communication? Because that modifies the message, right, on the way to the receiver. We think of this as dropping bits with a noise source, but it's something that makes a different meaning. So I'm going to lay over top of Shannon's model this sort of picture. And I think of this as a model for what I mean when I talk about expressive robotic systems. They are things that can communicate internal state through external change. And so what is the source? Well, maybe a robot. It could also be a moving natural system as well. But some moving system is my source. Some other moving system with some other body is my receiver. And then the channel, the environment, or the context in which this interaction happens changes what it means. We played around with that on Thursday, yesterday, a lot, right? And we flipped that. And so this is a nice mental model for like what this is. And Wednesday's talk was entirely organized around this model. The fourth thing that Wednesday's talk used was this idea that I need a test bed to figure out how this works. And the only test bed that I can think of, I'm sure there's a million, but I have a bias, right? But the test bed that I try to use to figure out this process is the theater and the performance and on-stage environment, because that is a place where I can change the context. I can change what the program note says. I can change what's on stage, who's on stage, how many things are on stage, what are they doing on stage. I can use lights to make it seem like it's dark outside versus light outside, because that's part of context. And that's what the theater is built to do. The theater is built to change context and allow us to communicate different ideas to audience members. So I won't really talk about this today, so let me just say, we use this in a very literal sense. We put on shows, we collect data from audience members who are sitting in the stage, or in the theater, sometimes only before and after, but also sometimes during. And so this is what we're working towards in my group, is to really understand this picture using performance as our test bed. So if this is exciting to you, go back and watch Wednesday's talk. But we'll see these elements show up, and I'll refer to this all the time because this is just truly how I think. And I really want to highlight this idea of the source, like how many bits. And if it's a moving device, and we model it with Newton's laws, the continuous equations that we think of describing motion, there's something is at odds there, right? Because we think of information as a discrete entity. So how do I get around that? And I am going to talk a little bit about that today again from Wednesday, because I just think it's really an important idea. The other important idea that we all have to get on the same page about is, what is dance? We were talking about this during lunch. What is dance? What is dance? So this is Catherine Elgin. She's a scholar at Harvard. She knows what dance is. I'm going to read this to you. It's going to be a little boring, but I have some animations. Swan Lake is beautiful. Here I have a picture of Swan Lake for you, so you know what that piece kind of looks like. It's a classical ballet piece. It is delicate, graceful, enchanting. Martha Graham's Night Journey is not. It is riveting, harrowing, horrifying, often ugly. Yvonne Rayner's Trio A isn't even that. Being utterly pedestrian, it does not play on the emotions at all, but it is intriguing. Taken together, these three dances raise questions. What is dance up to? What does it do, and how does it do it? Night Journey discredits the thesis that the end of dance is beauty. Trio A discredits the thesis that the end is affective engagement, affect with an A, so dealing with the emotions. Possibly dance has no such end. Different works and different genres pursue different ends, but whether or not dance has a telos, questions arise. What does this particular dance do? How does it do it, and why? My thesis is that dance embodies and conveys understanding. We emerge from a performance of such work better equipped to recognize such features, like political ideas, emotions, etc., in other situations where we encounter them. So erase the idea of tutus and point shoes. I mean, that's part of dance. But dance is about communicating through movement. Often nonverbal, but often there's text, often there's scripts, often there's all, and speaking is movement too, right? So I have this sort of broad idea and very utilitarian point of view on what dance is, and how it's used in my lab is as an intellectual academic pursuit that helps us do what we want to do. So if human movement, if dance communicates information, then what is human movement? And I don't know the answer to this. I truly don't. And I understand so much how much I don't understand the answer to this. So I have a few slides that hopefully will confuse you too. So this is an experiment, maybe done at Purdue, maybe not, I'm not sure, done by Frank and Lillian Gilbreth, kind of like an early motion capture. And I just like it because it's so visual. Like, what is human movement? Like, it's so messy. Look how chaotic. I mean, these are just maybe even minutes of data capture, I would guess. And it's just all over the place. And then we have this idea too, right? Use in my work is something called the Laban Bartenieff Movement System. It was begun by this guy, Rudolf Laban, and this is images from the 1930s or so when he was working with dancers. And in a second, first of all, we see structure. We see that he's playing with some idea about movement in unison. And he also thinks about this idea of the icosahedron as a platonic solid that, we could think of me inside of a not a tetrahedron, what's the other one? The octahedron, right? Where I have these like dimensional poles. I can move in one dimension or this dimension. I could be inside of a cube, and I move now with 3 dimensions inside my spatial intent. He thought that people tended to move inside the icosahedron, which is neither dimensional and purely rarefied or super complex and 3-dimensional, but sort of somewhere in between. And this idea that we're sort of in between ideals when we move is very fascinating to me. So that's the sort of generative side. But we are also human, we also perceive motion. So let's look at that side of the picture. You've seen this before, I hope. But the point with this is work by Fritz Heidel and Marianne Simmel, or maybe I have their first names mixed up. And this is like a 1944 experiment where they were kind of surprised to see, they call it apparent behavior, right? That these little shapes wiggling around on screen seem to tell a story. And I think one way we could think about this work is that actually people just make up stories about whatever it is they're seeing, no matter what, including about robots. So what stories are people telling about robots? Oh, can you see it? It's a Roomba and a cat. I mean, there's 1,000 of these on the internet. And this guy has made this whole narrative about what the Roomba is doing and what the cat is doing, and he's narrating it over the speaker. But I like it because you see that the cat thinks that the thing is trying to say something. It's trying to figure out what it's saying. And And there's all sorts of stories being told that iRobot has no control over, right? Has not designed for. That affects how this cat is moving around the machine. So we have this idea that human movement is two things. It's the generation and the interpretation of information, complexity, chaos. And so the way I have thought about that in my group, and now I want to I'm going to try to give you a little bit of an overview of a few projects and then just take you through how we might work through one, because we've talked a lot about process this week, and so this will give you a sense of what our process looks like. And the first thing to notice is that our process is a little chaotic and all over the place. But we work inside design loops. We work inside of iteration. This is a project where sort of from two endpoints, the structure you should see on the screen is that on one side, we're going into an assisted living home, talking to people who work there about what their pain points are. You know, we tend to work in a very agnostic way of like, we just want to understand good use cases where assistance is needed as a sort of point of inspiration. But we also may want to communicate different characters. So we could work from the arts. We could take an opera like Tristan and Isolde and try to understand, could we take one robot and another robot and make two distinctly looking different patterns in motion that communicate two different characters? And so these sort of form these working processes where we design maybe a robot, or maybe we design the motion of a robot up in the upper left, and we watch it, and we read it, and then we go back and we change it. Okay, maybe this variation needs to be a little different. And so here you're seeing a bits of motif from the Laban movement system that notate the kind of quality that a movement has. And then we show it to random people. Right? And we say, did you see something? Or we put it on stage and we ask people, did you see something? So I think of, you know, this top experiment used Amazon Turk. The bottom used a live performance, but both involved lay viewers as well as expert viewers. Another work that we're doing, and I'm going to talk more about this one today, is looking at gait. Right? I don't want just one gait. How many synonyms for walking do you think we have? I already told people on Wednesday, but how many synonyms for walking? In the English language, 50. Oh, that's so close. Good. Yeah, 62. So we have 6 that we validated. So drag versus shuffle versus amble. We're going to talk about this, and I'm going to model this project. But we're trying to think, how many different gaits can we talk about, or can we generate? And then finally, another idea of how many different robots can we move the same movement phrase on? And so this little video shows this idea, are these the same thing? And here again, we have to work with people. Like, we know physically it's not the same thing. One has 1 degree of freedom, one has 2 degrees of freedom, one has like, I don't know, 26 degrees of freedom. And they're not the same thing, but sometimes people think they're the same thing. So what is that? That's about the receiver and that decoding process and some sort of perceptual thing that happens, that even when they're not the same thing, we can think they are.
I have a question about the question that you asked me. I guess it's here. The next slide.
The gates.
Yeah, the gates. Yeah. So how many of those 62 do you think are perceptible with that stick figure?
Great question. I don't know. Kind of an empirical question. It's an empirical question. So I know at least 6 are. That's as close as I've gotten.
And is that and what's the generative process for creating these gates?
Yeah. So I talked about that a lot on Wednesday, and I have a slide that'll answer that question.
Sounds good.
Yeah. But this is just thinking about this process of design, and I wanted just to kind of highlight 2 things about it, right? One is that we work very top down, from the human body to a simple system. And the other, let me, it bears repeating, that this idea that we start in the human body, we ask, I'm skipping ahead this idea, how dancers talk about human walking is very different than how maybe you might think. So it's often the emphasis is on the pelvis. And so with this project, we wanted to see if we could simulate the weight of a heavy pelvis. And so this is what this little idea was. This is in VREP. It's kind of a terrible effort in some way, right? But we have this thought that if we had a heavy rolling ball in some kind of channel that we could control, we could initiate gate from the center, which feels more natural to the way Irmgard Bartenieff writes about it in the Laban system. And then we can simplify it and make something robust, and then we can try and take that robust thing and turn it into many things. And so it's this sort of complex to simple way of working, as opposed to like, if I have these two doohickeys and I put them together, what can I make it do, which would be more bottom up. And then this idea of working both with experts and lay viewers, I think, is really important part of this process. Once I have something, what do I have? What do I see? What do I name it? How do I present it to a lay person in order for them to make meaning out of it? And so that's sort of this interior label we're going to try today, hopefully as a group, where we think about iterating within the lab. Okay, let's make this variation a little different, a little that. I see this is moving faster than that one, and I notice it, so maybe that'll read for people in certain contexts. And then we think about lay user studies on Amazon Turk. So let's just ask a bunch of people and see if they validate what we're seeing. And that's how we think about validating these different styles. So let's try that. So let's say we wanted to do a drag and a saunter, two different words that can describe walking. Here's a definition and then an example of each one. So drag, to trail, to hang with its weight while moving or being moved, to move with friction on the ground or surface. I have to drag myself out of bed each day. Different idea than saunter, walk leisurely with no apparent aim. In June, some flights were delayed at Kennedy when about 100 turtles seeking a place to lay their eggs sauntered across the runway. So these are examples, and actually we use these in user studies to train people on what these words mean.
It's like a very inappropriate use of the word saunter in that sentence. Like they were seeking a place to lay their eggs. That doesn't seem sauntering. It seems very, very purposeful. I'm offended for those turtles. I'm actually mildly serious.
Well, I actually think this is an interesting point, which we could philosophize about a little. We could say that, you know, because the turtle has this foreign body to us and it has this little sense of waddling already, we interpret what's very serious work and behavior from the turtle as a saunter. And I am also now offended too. You're right. No, like, yeah.
You know, connection to the previous question that I asked also, which is that these phrases that we use are very human, and they come from not just the biomechanics of how we move, but also context and how what we wear, how we feel.
Yeah.
Charlie Chaplin walking across the street is very different from me walking across the street.
Yeah.
Because there's a lot of meta context about his movement.
Yep. Yes. 100%. So here's how we're generating these gates. I talked a little bit more about this on Wednesday, but the idea that we have a feasibility problem here, where we have some constant cost and a bunch of constraints, most of which have to do with recreating periodic gait that doesn't like launch the, or violate the laws of physics, let's say. And we have two parameters, thigh lift and pelvic shift, that we relate to this idea from Bartenieff's work. And we make them modifiable, like they're just a parameter, like 1.1 and 2.2, and I can vary them across a wide range. And by varying them across a wide range, I can generate hundreds of different gaits, not all perceptually distinct, right? And so let's look at 3.
Yeah. Quick question about the previous slide. What is J?
100.
No, but what is it? You have to define what J is. Is it energy? Is it
It's just the number 100. So it's just a constant cost.
J is a function of U, but what is it? Is the cost of? Is it energetic cost? Is it?
No, it's not.
Okay.
So it's just it is going to give. I'm going to minimize J to get you, and in this case, it's a trivial function. It's just 100, just a constant number.
Okay. So you're just satisfying.
So it's like a feasibility problem, not as opposed to like an optimization problem. Mm-hmm. So I mean, I don't know if I'm just generating what I think you're thinking, but like we're not really thinking about minimum energy.
If they were 100 or 4, it would be the same thing.
Yeah.
Okay.
Just a constant. So just to set up this feasibility problem. I don't really care about minimum energy, although it's an important idea. But here I want 100 different gates. So some of them are not going to be minimum energy.
And are you ensuring like periodicity in some way here? Like single
Yeah.
cycle periodicity, multi-cycle? Like,
Single cycle,
okay.
yes.
Okay.
So we have some gates. I would like everyone to stand up and try the gates, just briefly. This room is feasible to walk around in. So what you're going to do, and I want you to think, we have 3 gates. We have 2, oh wait, I have another slide for this. So we're getting up, we're walking around. Here's our goal, is to find drag and to find saunter. And we have to get up, because it's meaningless if we don't get up and move it. Because exactly Sid's point. All of these words are human, and they're made for human bodies. So pick a gate, come up with some hypotheses about which might be drag or saunter. And we'll talk. So I'm going to do the first one. And I'm going to, I sort of skipped over this idea, but this little thing in the center is my pelvis, and these little things are the legs. And we train users on this in the studies too, where we like put them next to a body. So swing your leg and take a little pause as you walk, right? Yep, beautiful. You guys are doing great. Try at least 2 of them, but hopefully all 3. It is. Think left foot, right foot, and watch the 2 little legs. Right, this one has. Yep. And a little bit of a pause before the foot comes forward. Yep, exactly. So any hypotheses about which might be drag or which might be saunter?
Top one is drag. The first one is drag.
I agree with that.
I think the second one seems saunter-like.
Mm.
For me, the third one seems like a strut. So it's like, look at me, I'm strutting.
Mm-hmm. 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 I like that idea too.
What do I know?
For me, the middle one is a little bit of a lope. There's a little bit more suspension, right? Whereas saunter, I feel like, is a little more strutty.
Oh. So you think the third one is a
I do.
is a saunter?
Yeah.
Oh.
but so we could. Oh, and I should have retained this.
A strut is like a saunter with some panache. Like this one certainly, like there's a saunter happening there. There's a little bit of panache. No?
I mean, this is the tip of the iceberg.
Okay.
I mean, yeah, right, of course. And so.
That leg moving backwards. See, if it didn't move so backwards, I'd be like, that's a saunter. But there's an element of panache to that saunter that makes me feel like it's a strut.
I mean, we should study this, right? Like, we should figure that out. I don't know. I mean, I know that people on Amazon Turk rate this well, says a saunter. But this is iterative, right? And it may not be the last definition of, so I hope to God this isn't the last definition of saunter, right? Because it's also only 2 degrees of freedom, 3 degrees of freedom, right? And what you're talking about is maybe, and when I did in my body, I'm like leveraging all these other degrees of freedom I have to specify an idea. And here I don't have that level of flexibility. And a big question we could ask, and then we're going to get to, is like, how impoverished is this versus our body? I think that's an important number to have quantity on, to ask these exact questions in a well-posed way.
I think like there's simply, just from the I had never heard this word, and I couldn't use my prior knowledge. Just from the definition, leisurely and no apparent aim is like you have time, you're not getting anywhere, and this particular one is like going backwards before going forward, and then going forward by coming back, right? So it's just very directly related from a very simple.
In agreement, you're saying. You're arguing for saunter, yeah. Yeah. I buy both too, right? And I think part of it is like we can only it's almost like a first order thing, right? Where we only have 3 degrees of freedom here. So I don't know that we could specify saunter over strut. It might not be possible because we might not have enough expressivity. I don't know the answer, but it might not be possible even. So saunter or strut might work. And I would argue, especially with our imperfect experimental protocol, that you could get both to do pretty well for that gait. One of the things we're working towards is a more brute force method of like showing people hundreds of gates and figuring out how similar two look relative to one another and then doing the labeling on like the clusters that emerge from that. But we're not there yet. So this is the question we're just debating. This is perfect, right? Like, can we even do the same things as we have written words about? I don't know. But it's an important question to ask. And I have this little point that I think is, this is work out of Steve Boker's lab, who's a psychologist. And what he has looked at is the role of imitation between two humans in conversation. And he uses just the lens of symmetry and like head angle and body posture to say that, and he has this virtual setup, which is a little hard to determine from these pictures, but he can take the face, he recognizes the face, and then he makes an avatar, and he can modulate how the avatar is mirroring. And he can make it mirror more or less than the real person was mirroring. And what he finds is he's actually able to disrupt the perceived quality of conversation by doing this trick, or this input. And so and there's all sorts of interesting things he's learned, like 2 women do it differently than 2 men. And so these dyadic interactions are important, but that symmetry is almost like a baseline maybe for communication. That might be too strong, but it's certainly an important part of our behavior and how we let someone know we understand what their internal state is. So imitation, are these 2 things the same? Yes or no? Pick. Shout it out.
Yes.
Are these 2 things the same?
No.
Are these 2 things the same? A bit more of a delay in this one between the 2. For reference, Jialu is about 5'7", and I'm about 5'2" on a good day. So there's that, right? I'm very long torsoed, she's very long-legged. So there's something different there too. Are these the same? And I appreciate that you're laughing. You're laughing because it's like, yeah, they kind of are, but of course, no, they aren't. So we can do really well with really simple things and seem perceptually the same. We've done this work too. We talked about this more on Wednesday, but this idea of what does it mean for this robot to do the disco? What does it mean for these? Oh, they're both playing. What does it mean for these robots to do the disco? And can we do that automatically? This paper is a wonderful paper that's been under review for over 3 years. But please go find it on archive. All right, now we're at my favorite. Are these the same? You know where I'm going with this, right? This is a great video to watch, by the way. He can teach you to do a backflip in 5 minutes, he says. Whoa. And listening to what he says is actually really useful. And I've tried to learn to do a backflip since this. It's really scary. But are they the same? One thing that I want to emphasize, and I wrote a whole article about this on Medium, is that if you watch this robot, it's very distally initiated. So the ankles and the arms are really important parts of how that thing happens, if you like slow down the video and watch it. He talks only about the hips, right? Jut from the hips, jut from the center. So that's a huge difference. I mean, of course, they could be the same while they're different from some abstraction level, but how different or how the same are they? And so I want to put these back out there as a way of answering that question quantitatively. So only look where I'm pointing. So this plot, this is just like Moore's law for robots. So on the x-axis, I have time. On the y-axis, I have the number of transistors. This is onboard transistors in the CPU of the robot, where data is available and estimated where it's not. It's a limiting picture of computation and internal state complexity because we have like Wi-Fi and like the whole internet at our disposal, right? But it's a picture about progress and change over time. The middle one, same x-axis, same set of 20 robots. The y-axis is the number of mechanical shapes, configurations, postural, static, instantaneous configurations that these robots can make based on their range of motion and based on the precision of their encoders and estimated where data is not available. So if I want to compare, back to that first wheel we talked about, internal complexity, external complexity, how many internal states are possible, how many external states are possible, what's the mapping between those things look like? If I want to compare the y-axes, I have to either go 2 to the 10 to the 11 to get the number of internal shapes, static moments in time, things that the little transistors can do to be in different, how many bits I need, right, would be the number of transistors. So 2 to the 11 to be comparable to the number of mechanical configurations. So what I'll do is I'll take the base, log base 2 of this y-axis to compare to that y-axis. So that's what I do over here. So over here on the x-axis is the number of bits that I need to describe the internal state of these machines. And the y-axis is the number of bits that I need to describe the shapes. And it's just an interesting trend, right? Where, so here I've made the maximum number on each axis the same so that we can kind of compare order of magnitude. And you see, over time, the internal state has like exploded. And I mentioned that it was a very limiting picture, both because it's a static measure and also because I have the internet. And then the y-axis is like how complex the external shape can be. And it stayed relatively constant in terms of order of magnitude trend. And what's also nice about this is I could ask what natural systems could I then compare if I did a similar analysis. It's not to say that what we know about robots versus humans is that like for decades, the maximum torque, the minimum torque, the speed, the precision, the repeatability, robots have been outperforming humans, right? We know that. That's old news. But there's still things we can do that they can't do. How do we measure those? How do we quantify those? It's not the only picture that we might use to think about robots, but it could be one interesting lens. And we could then compare to humans, maybe. So in blue, I have like borderline made-up numbers. In black, I have numbers I feel pretty certain about. So when I go to the natural kingdom, we don't understand motion. That's where we started. I don't know what human motion is. But I do kind of know what C. elegans motion is, or Greg Stevens really knows what C. elegans motion is. And he has used 100 joint angles, so this top button, C. elegans anatomy, that black circle. He uses 100 joint angles to describe the posture of the worm. He watches the worm for hours. He does linear decomposition on the data. He finds that there's 4 postures that span 95% of the data set. He calls them eigenworms. And that's this model here. So there I only need 4 numbers, and you can look at the precision that he reports these numbers with. You can look at the range of observed values for each of these coefficients, and you can get a sense of the complexity of that model. It's like a compression, right, of the original model. I have a lot of longer discussion about why I think it's the upper number, not the lower number. But either way, one of these numbers seems to model well the complexity of C. elegans motion. And all of these robots fit kind of in between those 2 numbers. So as a apt natural correlate, I humbly suggest that maybe C. elegans are a good one when we think about these platforms in terms of what they can do from the lens of entropy or complexity. These other ones, I mean, you could imagine I can make up all sorts of numbers for humans, but the interesting one up here at the top right, this is from an animator study where they modeled just the rib cage during breath. And they use like 10,000 springs, essentially, to do that, to get the shadows to look right in their animations. So that's just the torso. And here I'm using on the y, I forgot to say on the x-axis, this is just number of neurons, which is also a big under-approximation in terms of how people think about neurons now. They're probably not like binary on or off. So this question then, are these the same? And I've added this little coin to be really dramatic. Like, yes, they're all backflips, but we have to think, like, how high fidelity are they in terms of the replication of one another, in terms of this idea of instantaneous complexity? So, I mean, I say no with 2 footnotes. They're not the same, but then they kind of are the same, right? So mechanically, they're not the same. And I'm really interested in this idea of how does entropy, what does that mean in mechanics where we model everything with these continuous models? But we can have abstractions that make them perceptually the same, obviously. And that's something I'm really interested in my lab, and I'm kind of, like, I think, running out of time to talk about. But let's at least do a quick deep dive into that, right? I use the Laban Movement System, and I'm going to go to backup slides to make this really quick. So remember this video where it made everyone kind of, no, I think it made just you laugh, but it made one person laugh, right? Are these the same? No, everyone said, but maybe they are the same. There's something similar about them, and we can see that similarity through the Laban Movement System. So here is a motif, a symbology of a movement idea written down, like a sentence. And this is what generated those 2 phrases. So we started with this, and then we made them from this. And this first one, if you came to the workshop, spoke-like mode of directional shape change. Joel reaches out. Oh, it's supposed to be arc-like, too. I still didn't fix that. It's arc-like. Joel reaches out. Manav reaches his neck, but both arc through space. Then gather, a basic body action, bringing things from out to in. Then flick, this moment of effort, quickness, lightness. That's that the snap. And then place low. They both end low. So it's not over-specifying what it can be, but it's finding that perceptual similarity through a vocabulary that artists and choreographers and physical therapists and other embodied practitioners use. So there is a lens through which they are the same. And then there's and it's only through an abstract lens that they could be the same, because Joel is taller than Manav, or they have different length arms, etc. So we need artists to figure out this design process. And I'm going to do 2 things. I'm going to show you what I did with the dance department on Wednesday, on Tuesday, whenever I got here. And I also want to just tell a quick story, because it matters how you feel about this stuff. And I want to just tell you how I have felt about it. So when I was a PhD student, and I'm kind of efficient, and I like to get things done. And when I finished my last class, and I told my PhD advisor, I finished my last class, I'm done with classes. And he kind of looked at me and he said, well, you know, Peter's taking real analysis too, and I really think you shouldn't think that you're just done now that you're done. And I was like, oh, he's probably right. Like, I'm not as good as Peter. I'm not as good as Peter. And I thought that for many years. I still think that, because Peter was like brilliant. But I have this master's student who's graduating this year, and on Friday, before the week ago, she presented as part of her master's thesis a dance performance. And in writing that thesis and in putting together that performance, she would come in and she would say, well, I've done all this stuff on the paper, I've done all this stuff. I'd say, well, what about the performance? Have you worked on the performance? And she would say, well, yeah, I'm going to do that. That's not as important. And what I realized in trying to tell her, I think it is as important. I think you should feel that it's important. Part of your expertise, she's a classically trained Indian dancer. She's beautiful. Go check my Twitter to see some of it. And the work that she did was informed by that training, right? And the things that she sees in movement is informed by that training. And what I realized is, I had taken a lot of extra classes on top of the requirements for my PhD. I took all sorts of ballet classes, all sorts of modern classes. I spent so much time in other classes. I did the field work where I learned about what we're about to do. So feel that this is important, right? And note that maybe you don't feel it as viscerally. I didn't feel it for many years, that it was really as explicitly as important as real analysis. But it certainly enables work, because it enables this kind of work. So what's going on in this picture? I did this with the dancers on Monday. What's going on? It'll take just a couple minutes. What do you see?
Pointing.
Ooh, beautiful. What else do you see?
Leaning forward.
Leaning. Wow. Damn, you guys just got straight to it, right? The robot is pointing instructively out into the distance. The robot is leaning casually into his human cohort. We use those two objective pieces of analysis to think that they're friends, to think that they're collaborating, to think that they're cohorts in some way. They're not antagonistic or enemies. And that writing of sentences and figuring out what's going on in that sentence is something I learned how to, or in that image is something I learned how to do as an artist. And so on Tuesday or Wednesday, when I was at the dance comp class, I gave them this smorgasbord of pictures, right, where we have human bodies and robot bodies put on the stage next to one another, and we've made some scene. And what we ended up talking about before I showed them this is like, what is a robot? Because they get really nervous about that question, actually, some of them. Like, what is a robot? I don't know how a robot works. I don't know what it is. I don't know how to make it move. What is it? And I think you could answer that, and I have heard people answer that in two very different ways. Some people would say it's an agent. Some people would say it's a tool. And the word derives from the arts, right, where we are thinking of like little agents, little demi-humans, but also we could think of it as a tool. And I think, you know, you could argue that in different pictures, a different idea is out there, right, about how it is, especially if you saw the piece that went with it. But what they did was try to recreate these pictures, translate these ideas to a new place, to a new context. And the way they would do that depends on their level of feeling about what is a robot, right? So I'm just showing you, number one, there's two things. You need artists. You've got a bunch of really talented artists that can think about things from a point of view here at the university, and here are some of them. So they took this photo from the smorgasbord, and they recreated it in this way. Notice this is a person with a shirt up over her head and little post-its in place of eyes. And how did they do that? They wrote sentences about the picture. Then they used the sentences to generate the new scene. This picture. They wrote sentences about the picture, observed it, analyzed it, recreated this scene. This one. You know what this one taught me about this picture, which I'd never realized? This was at my lab at my PhD. This woman here has all these green Post-it notes on her, and they have little things like I equals VR and dancer plus artist equals superwoman, or, you know, they're little, like, she's poking fun at the ostentatiousness of this wall that's full of like technical looking equations. And I was like, that's a detail I had not noticed before, but they're totally right about. And then this one. And it's interesting, the choice, right? The choice of a human to replace the robot agent versus a chair to replace the table. But what if it was two chairs stacked on one another and two people on either side of it? Then it means something totally different. So this is important, right? We want robots in so many new scenarios where the communication of internal state through external change is like key to surviving, right? Or where really delicate, fine, complicated movements that change every day are key to survival, like an artisan, right? So, and I really appreciate your time. I have time for questions still, and I'm really looking forward to what you might be thinking. Thank you.
Questions?
Can I ask an
Yeah.
off-the-wall question?
Please.
Or literally it was off the box or off the... So it's fascinating to me, and I'm just curious what you think about this. When the Boston Dynamics backflip happens, having studied movement or understanding kinesiology, that looks like it has to be fake.
Mm-hmm.
I can't, because I think I'm picturing the musculature of like how the human body creates enough energy to create that movement. And whenever I watch it, it's like it breaks my brain because it seems physically impossible to be correct.
Well, I love this question, and I'm not going to answer it. because I don't work at Boston Dynamics. But what I'm going to answer is a different question, because this reminds me of this whole gait project. And I glazed over this too fast today. But this idea of thigh lift, forward pelvic shift, lateral pelvic shift as being the primary components of walking, as opposed to nothing about the ankles, right, is an idea that was completely generated from my, and I write about it but my dance teacher, in one of those classes I was taking that I wasn't getting credit for at Georgia Tech, in my dance class, my dance teacher came to my performance that I did with my PhD dissertation. And he came, and after the show, he came up to me and he said, and I used the little humanoid robot in the show. And after the show, he came up to me and he was like, how does that robot move? And I was like, oh, well, I have this Wi-Fi router, and I use this computer, and I've written this program, and it has these little servos in every joint. And he was like, no, I'm not talking about, that's nice. But like, how is it possible that it's able to stand up? It doesn't have a core. It doesn't have a spine. Well, I don't know how to even understand that, because when I teach people to stand and walk and move, it is through their spine and through their pelvis. And that thing doesn't even have a bendable joint there. So how can it move? And I was like, truly like, I don't know, I've never even thought about the fact that it doesn't have a core. It doesn't have a core because it's hard to build the core, and like, we're not going to do that. I didn't know what to say. But that thing just sat in my mind, and the blessing that he was there to ask me that and show me that. And then when I got this PhD student, it was like, I want to study walking. And I was like, I don't do walking. And then I was like, but I do have this thought, about core and pelvis. And so now his whole PhD thesis is about walking. And it's about Greg's idea that like, oh, why is it even able to move? And then we talk a lot about like, sometimes I show all the robots falling at the DARPA Robotics Challenge. And I say, when I touch something, I change, the whole physics of this. And what I did there is a subtle shift, right, from my pelvis. I didn't move my ankles are moving, yes, but like the heavy thing that's moving is my pelvis, and it's changing my center of mass. And so now I could like push on this thing and not fall over. And I'm accommodating here. So I think that was related to your question.
But it just also comes back to the idea that if we create, like the robot is doing a backflip, but to me, it doesn't have any of the expressivity, or it communicates something completely different to me than the human doing the backflip.
Yeah, and you see that in this moment, right? After the backflip, it goes, and like, right? Where is all of that?
Right.
Yeah, I agree.
So I feel like mechanically we can get there, but I can still imagine how
This is mechanical. What I just did is mechanical.
But it's just, are we going back to the turtle thing again? Like, are you interpreting something of that robot that perhaps it wasn't trying to convey?
Right, well, and that's what I think it is. It's like a miscommunication.
But it can't convey, Sid, right? It can only lift its shoulders. It cannot do this versus this. It can't do it. It doesn't have enough degrees of freedom to distinguish between this, and this.
Yes, but if we...
So she's not misinterpreting. She's pointing out that it's not there.
No, I guess I'm saying that if we understood its inabilities, this would be like saying that someone with let's say a physical deformity did a backflip. Would we be...
It would still have way more access to external state changes than the Boston Dynamics robot.
Okay. No, I guess my point being that, like, perhaps, the physicality, the ability or inability of its physicality and our familiarity with its physical existence is forcing us to make certain decisions about it. Whereas, maybe if we spent a few months hanging out with a robot.
Oh, yeah. And I have a great example of this, right? My coffee maker has this very helpful LED on it. And after months and months of being with my coffee maker, I know what that LED means. No, it's true.
Yeah.
So yeah, you're right.
My coffee maker
But
makes
she's
a
also
sigh
right.
at the end of making coffee.
Right,
It's
and it's triggered with this Pavlovian reflex, right? Of
Thank you for making me my coffee.
Yeah,
It's my
agreed.
burst of steam.
Right.
But, no, I guess you talked about sort of the transmission of information, and I think that's a good paradigm to think about. And I guess part of the challenge here is that we come with inherent biases about how we want to interpret anything.
That's the receiver part. That's the receiver part.
Yeah, and it's trainable. So I guess there's like something interestingly Bayesian about this whole thing of like, even before I see this robot, I have some perception of how I would respond to it. And then
well, you're assuming a model, right? Like I want to start from the place where we don't assume if it's Bayesian, we don't assume if it's linear, we don't assume if it's not. We're just observing like like Newton under the tree, right? Like I notice that this is happening. I see that I don't see. What she's doing is observing that it's not happening. I don't know if it's Bayesian or not. I mean, I don't know what's happening.
Well, we can argue about whether everything is Bayesian.
Yeah,
or
we
not.
can, yeah.
But
I'm a frequentist.
well, you're just wrong. But that's okay.
But I'm not alone. But I'm not alone. There are other frequentists in the rooms.
But well, I guess the coming back to the subject matter.
But that process is part of the subject matter. And the process of assumption about the model or assumption about what's possible, instead of looking and seeing what's happening first, is the process, is the work, is the whole. That's why we started with the little gates and the words, and we did it in our bodies, and we didn't start from, there are 5 things, and I can make these 5 things, right? As a model, which would be a model.
I guess the meta question is, like, in the end, like, what do I take away from the talk, or what would I want my robot to do? It would be generative, right? Like I like my robot to be able to generate behavior, such that it can be expressive, legible, intentional, whatever it wants to be. And then.
But I think the hope that you take away from the talk is, rather than thinking that a movement that looked happy to you was expressive, that the way you think of that word is that it's like, do I have red, blue, and yellow? Or do I have just red and blue? Or do I have red, blue, and yellow, and orange and purple and green and white and black on my palette? Because that's an expressive system, a thing that can do many things, any of which could mean any number of different things.
I mean, let's take the two-legged walker example, right? I understand that the different people interpret different gates differently.
And very differently in different contexts.
But I think that like in the end, if I'm a builder of walkers, I want to create a generative gate that enables me to convey the information that I want. Right? I need to invert your model. Right? I need to be able to go from this is what a gate is to this is how I want to create a gate. This is me. I'm just saying what I want. It might not be what you want. And then I guess I'm trying to understand how that inversion can happen. Right? And to make that inversion, you need to have some sort of model that helps you invert it. Right? Unless you see.
I mean, I want a button with the meaning of life too, and I just press it, and it tells me how to do everything. But I mean, humans are human, right? We had to get up and we had to move it to know what it was, because it has to be situated in human experience to be meaningful. I would love to know if there are other questions too, because I feel like I've gone off the deep end with you a little, but I appreciate it so much.
Okay. Because I'm also on Sid's side of like, I want the robot to convey a particular thing.
Yeah.
Like I want the receiver to have a certain impression or emotion. So what should I do on the robot side?
Right.
So I was thinking like a really simple example, maybe like Roomba. If Roomba, like if I'm the designer of Roomba and I wanted to, through motion express when its battery is low or something like that. Is it, in your process, there's definitely, I could randomly generate many different motions and get Turkers to rate them and figure out which one is like perceived as, oh, it's tired. But is there something more than random for us to say, for tired, this is what I should do, like dance has taught me.
Well, we can use empirical measurements about humans to derive models, right? And that is totally something let me show you this example. So we took a bunch of gates that were labeled as this in a paper, neutral, happy, sad, energetic, tired, whatever. And we put them on new backgrounds, right? And we ran these Turk studies, like what do people think? And actually, we find the first point is that they find, like, they don't so red is the wrong label, blue is the right label. So it's mostly red. They label them like crazy people. Like there's no pattern, right? A little bit. So if you look at happy, second one down here, right above my finger, happy is labeled basically randomly. And it's, if anything, it's labeled feminine, not happy. If I come down to masculine, it does quite well. Like it's very repeatable and is labeled very frequently the right thing. More descriptive label over the emotive label. That's the first piece. And then we can also, what do I think is happening in the original experiment? It has something to do with people making up the right background in their head. And so if we redo the experiment and we ask them where it took place, there's some trends in what they reply with. But we can make a model. We can use the circumplex model of affect that we were talking about before. We can rate the walking by itself. We can rate the background by itself. And then we can create a predictive model that says what I think is going to be rated if I do this in this context. And if you note that, here's my walking, here's my context, it's about and one number is valence and one number is affect. No, that's not right. One number is valence and one number is arousal. We had bad spread on our arousal, so we don't have a very good fit there. But it's about half and half between context and gait to determine the valence of the new stimulus when we do this recombination. We can predict. We have to make the observation first. We have to do the measurement first, because humans are an empirical, unknown, wild thing.
I kind of want to note of culture, I guess. Also, as a physicist, I'm a little bit sympathetic to thinking of this myself, so I wanted to.
Oh, thank you.
But I was wondering, you mentioned that you had a master's degree trained in Indian classical dance, and most of your examples throughout the slides were kind of more ballet oriented.
Yeah.
And I was wondering what you found the differences to be in the different kinds of motion and how that affected whatever they were studying.
Yeah. No, and that's my bias and my background. And that's what's been so cool having her in my group. And so what her whole performance last week was about was, we had developed this idea of verticality in the spine as being really a good low-dimensional measure of human movement that predicted behavior in some settings, sort of. And we used it to drive those the little broom and the little thing with the mocap skeleton in between. That's driven by that idea of what's the angle of the spine. And what she, in her training, and I'm going to butcher the names because I'm ignorant of it, but Bartenieff is one style of classical Indian dance, and Kathak is another. And one of the biggest things that differentiates those two styles is the tension in the hands. Like, are the hands extended? And she's taught me some of the things. I'm learning some of them. But is it really taut or is it more relaxed? Verticality doesn't measure that. And so she did this performance where she was kind of ghosting this signal, right? Like they couldn't tell the difference between these two styles. And it was developed inside a very Western context where Merce Cunningham does this while Mark Morris is more up here. And that measure was meaningful between those two styles. But it's not between all. And so it is totally dependent on context, and culture is part of maybe the biggest part of context. Well, I don't know what the biggest part is. But yeah, so and that's why, it's also about how complicated do you think the source is. If you think the source is only 20 or 30 bits, it doesn't matter if you look at the spine and the hands and the wrists and the feet and the elbows and the ears. But if you think that the source is like 1 trillion bits, you need to pay attention to all those things to identify it. So, that answer, yeah. I love all the questions so much, and I hope that we keep talking because I think you guys have such a great perspective here. And after 3 days, I would know. So thank you for having me.